Imagine the unimaginable, a cloud of dust and gas millions of miles across collapsing under its own gravity. What's happening here? You're witnessing the birth of a star, an event as common as it is wondrous in the vast expanse of the cosmos. It begins in nebulae, these magnificent interstellar nurseries of dust and gas. The gravitational forces at play within these clouds cause them to collapse inward, giving rise to a protostar. This infant star continues to grow, relentlessly collecting more and more matter from the surrounding cloud. Slowly but surely, the protostar's core becomes dense and hot, and then it happens. The moment of ignition. Nuclear fusion begins in earnest, releasing vast amounts of energy and light. The protostar has now graduated, becoming a fully fledged star, and there you have it. A star is born, not with a bang, but with a gentle cosmic sigh. Now that our star is born, what next? How does it live out its life? Well, imagine a star as a living being, having just entered its youthful prime. This is the main sequence, the longest stage of a star's life. During this period, our star maintains a steady balance, a celestial dance if you will, between the inward pull of gravity and the outward push of pressure from its nuclear reactions. At the heart of this dance is a process called nuclear fusion, where hydrogen atoms at the star's core collide and fuse to form helium. This reaction releases a tremendous amount of energy, illuminating the star and causing it to shine brightly in the cosmos. Think of this as a star's day job, a routine it maintains for the majority of its life, which can span billions of years. It's a time of stability and radiance, a star's golden age. This is the prime of a star's life, a period of stability and light that can last billions of years. But all good things must come to an end. What happens when a star begins to die? As a star exhausts its hydrogen fuel, a transformation takes place. Depleted of this cosmic fuel, the star begins to burn helium instead. This shift in nuclear fusion causes the star to expand, swelling to many times its original size. It turns into a red giant, a celestial body that is as fascinating as it is fearsome. This red giant phase is a remarkable sight, a fiery globe that engulfs the celestial arena. But for smaller stars, this is their final hurrah. Once they've exhausted all their helium fuel, these stars meet their inevitable end. Their outer layers are cast off into the cosmos, an ethereal spectacle of stardust and gas. This ejection leaves behind a white dwarf, a remnant of the star's once vibrant core. This white dwarf is a dense, hot core, a testament to the star's fiery past. Yet even this white dwarf does not remain hot forever. Over billions of years it slowly cools down, its heat dissipating into the vast, cold expanse of the universe. From a blazing sphere of energy it turns into a cool, dim object, a dying ember in the cosmic hearth. From a fiery furnace to a dying ember, such is the fate of smaller stars. But what about larger stars, those with more than 8 times the mass of our sun? Their fate is a little more explosive. You see, these celestial heavyweights also evolve into red giants. However, their increased mass triggers a far more violent reaction. As the core runs out of fuel, it can't withstand the crushing force of gravity and collapses in on itself, causing a cataclysmic event known as a supernova. This explosion is so powerful that it outshines an entire galaxy, even if only for a brief moment. What's left behind after this cosmic spectacle? Well, if the star was big, but not too big, we get a neutron star. These are incredibly dense objects, so dense in fact, that a sugar cube-sized amount of neutron star matter would weigh about as much as a mountain. And if the star was truly massive, we might get something even more mysterious, a black hole. And so, from a humble cloud of dust and gas, to a cosmic giant, to a spectacular explosion such as the life cycle of a star. It's a cosmic circle of life, isn't it? Stars are born, they live, and then they die, returning their elements back to the universe. They start as nebulous entities, evolve into a stable state, expand into red giants and meet their fate as white dwarfs, neutron stars or black holes. This celestial dance is a never-ending cycle, an eternal ebb and flow of cosmic energy. Subscribe to our Universal Universe channel for daily cosmic adventures. Until next time, remember, we are all made of star stuff.